All right. Today we're going to work on homework 29. It's not difficult, but I really wish you guys could be in class to do this, but I guess that's not going to happen. So we're going to start into trigonometry. Trigonometry is the study of triangles. More specifically, how the side lengths of a triangle is related to the angles inside that same triangle. So in this class we're going to deal with right triangles. So every single one of these will be a right triangle. And we're going to name the angles, and then we're going to have side lengths accordingly. So the most common right triangle that we deal with is a 3 4 5 right triangle. Now, every right triangle has legs. So the two short sides are called legs, and then the long side is called the hypotenuse. The hypotenuse. Okay? And then we have three angles. We have the right angle, and we're going to sort of ignore the right angle in trigonometry. We can't really use it in this class. That's sort of a lie. You can use the right triangle, or the right angle, but you have to use formulas that are way beyond this class, so we're not going to worry about it. So we're going to have the other two angles, and I'm just going to call one of them A and one of them B. Now, if you can understand this next step, then today is going to be really easy. Okay? When we look at either angle A or B, so let's start with A, looking at angle A, all three sides can be labeled according to how they interact with angle A. Now, the hypotenuse is always the hypotenuse. So I'm just going to put an H there for hypotenuse. And then the two legs either touch A or don't touch A. So this side right here does touch A. And it's right next to angle A, and the geometric word for right next to is adjacent. Adjacent. Okay? And then side 4 does not touch angle A. So this side is called opposite. And those are the names of the three sides with relation to angle A. So for angle A, the opposite side has a length of 4. The adjacent side has a length of 3, and then the hypotenuse is always the hypotenuse. Now, sometimes we don't want to look at angle A, we actually want to look at angle B. What does that do? Well, the hypotenuse doesn't change, H is still in the same place, but now this adjacent piece moves over here, and the opposite piece moves over here. So the opposite and the adjacent are dependent upon which angle you choose. If you choose angle B, then 3 is the opposite. If you choose angle A, then 4 is the opposite. And now you want to know, which angle do you pick? Well, the problem will tell you most of the time which angle to pick. And if they don't tell you, then it doesn't really matter. Okay? So let's open a new triangle. Call this B and C. Again, you can call them anything you want. And let's do the same 3, 4, 5. Well, what are the names of the sides? If this is the angle I'm looking at, if I'm choosing angle B, then this would be adjacent, and this would be opposite, and this one is hypotenuse. But if I choose angle C, then the O and the A switch places, like that. Okay? Now, I told you that trigonometry has to do with the relationship between the sides and the angles. So, we have created three ratios that put together angles and sides into one equation. Okay? And those ratios are called sine, cosine, and tangent. Now, to be honest, I have no idea where those names came from. And we're really lazy. Oh, it's not sin, it's sine. There we go. Sine, cosine, and tangent. But we're really lazy in the math world, so we abbreviate everything. So we just abbreviate sin, cos, and tan, and never say it that way or we'll make fun of you. So we have the abbreviation for sine, the abbreviation for cosine, and the abbreviation for tangent. And we use a new variable that you've never seen before, and it's called theta. It's a Greek letter, theta, and it's kind of a 0 with a little line. That was bad. With a little line across the middle, like a 0 that's wearing a belt. Okay? And theta always means angle. So theta has to be an angle, whether it's in a circle or a triangle or a square, whatever. Theta is always an angle. And so we say the sine of theta, the cosine of theta, and the tangent of theta. Okay, here's where it gets a little bit tricky. So I really wish you could be in class so you could ask questions. But the sine of theta is always calculated by taking the opposite side, whatever it is, and you divide it by the length of the hypotenuse. Okay, so if you want to know what the sine of theta is, then you take the opposite length and you divide it by the length of the hypotenuse. But once again, we're super lazy, so we're just going to say O over H. So the sine is the opposite side divided by the hypotenuse. Okay, the cosine is the adjacent divided by the hypotenuse, and the tangent is the opposite divided by the adjacent. Now it turns out there are 3 other ratios out there. They're called secant, cosecant, and cotangent, but you don't have to worry about those this year. All we're going to worry about is sine, cosine, and tangent. And this is going to seem really weird for a little bit, and then hopefully it will make a lot of sense. Now, how do we memorize that? How do we memorize that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent? Well, we have this cool mnemonic, SOHCAHTOA. And you can see sine is O over H, cosine is A over H, and tangent is O over A. And you're saying, Mr. White, great. Now I have to memorize some weird word. Well, once upon a time, a really snarky kid taught me the trick. He said, this mnemonic stands for some old hippie caught another hippie tripping on acid. We just say SOHCAHTOA. SOHCAHTOA. Some old hippie caught another hippie tripping on acid. Now you'll never forget it. So, what do we do with this? Well, let me get rid of a couple things. Well, let's say that you wanted to know what is the sine of C. Oh, shoot. Sorry. The sine of C. Well, that tells me which angle to pick. So I pick angle C, and then I look at my triangle. This is hypotenuse. 4 is touching the C, so it is adjacent, and 3 is not touching the C, so it is opposite. And the sine is opposite divided by hypotenuse. So all I have to do is look at angle C and take the O side and divide it by the H side. So that would be O divided by H, which is going to be 3 over 5. So the sine of C is 3 over 5. Okay? Let's go back a ways. Let's say I wanted to do, what is the tangent of B? Well, B is now where I'm looking. 5 stays the H, 3 is the A, and 4 is the opposite. And tangent, TOA, tangent is O divided by A. So I take the O side, which is 4, and I divide it by the A side, which is 3, and the tangent of B is 4 over 3. Okay, let's do another one. What about the cosine of B? Well, now I look at angle B. Here's angle B. And I want to do the cosine. Cosine is A over H, or over here you see A over H. So if this is B, 5 will be H, and this is A. So A over H is going to be 3 over 5. Okay, let's do a different triangle. Let's do G and F. Here's the right angle, 6, 8, 10. And our mnemonic is SOHCAHTOA. SOHCAHTOA. All right, so let's do the tangent of F. So tangent is O over A. If I look at angle F, O is going to be the 6, and A is going to be the 8. 6 over 8, and that actually simplifies to be 3/4. Okay, what about the cosine of G? Well, if I pick angle G, A and H. So with G, this is A and this is H. So that is 6 over 10, which simplifies to be 3/5. Okay. What about the sine of G? Well, sine is O over H. So if this is G, O is going to be that side, and H is always 10. So 8 over 10, which simplifies to be 4/5. Okay, that should be enough to do homework 29. Good luck.